Chapter 10, Problem 54. A uniform solid disk and a uniform hoop are placed side by side at the top of an incline of height h. If they are released from rest and roll without slipping, which object reaches the bottom first? Verify your answer by calculating their speeds when they reach the bottom in terms of h. You are given height and it is equal to h. You are to find speeds of the disks in terms of h at bottom. Using kinematic equations, k is equal to 1/2 mv squared plus 1/2 I omega squared, and then you can simplify that into 1/2 parentheses m plus I over r squared times v squared, when omega is equal to v over r because there is no slipping. And basically, Ui, which is potential energy, is equal to mgh, Uf is equal to 0, and Vi is equal to 0. Setting kinetic energy equal to potential energy, 1/2 parentheses m plus I over r squared times v squared is equal to mgh. Solving for v squared is equal to 2gh over 1 plus I over mr squared, and then I is equal to 1/2 mr squared for a disk. Plugging in I equals 1/2 mr squared in for I in the equation v squared equals 2gh over 1 plus I over mr squared, that will simplify and cancel out the mr squareds in the denominator of the numerator and denominator of the bottom term, and then you're left with v squared is equal to 2gh over 1 plus 1/2. Solving for v, you multiply both numerator and denominator by 2, and then take the square root. So you're left with v disk is equal to the square root of 4gh over 3. I for a ring is equal to mr squared. Therefore, for a ring, v squared is equal to 2gh over 2. Solving for v ring is equal to the square root of gh, and therefore we can conclude that v disk is greater than v ring.